Hey everyone, thank you so much for joining the Behind Company Lines podcast. Today we have Nate Hamet, the CEO and co-founder at Quindar. They are an aerospace startup focused on automation and automating the satellite design, test, and operation processes. Nate, thank you so much for joining the show. I'm really excited to jump into your background and your experience and what you're doing at Quindar. Before we get into all that good stuff, what were you doing before you started the company?
Yeah, Julian, thanks for having me on. So before I started the company, I was working at an aerospace startup that was doing synthetic aperture radar operations, and so it's kind of the flavor of the year and in the Earth observation realm for aerospace, being able to take pictures with radar so that you can image an area on the ground, an area of interest they call it, at night, during the day through cloud cover. So something that the government is very interested in as well. And then before that, I was at OneWeb, which is a broadband company via satellites. And they started around 2013, 14. So I joined a few years later and was tasked with creating the ground system that was able to talk to the satellites. And at that point, they were looking at 1,500 satellites. And in 2016 or so, Planet maybe had the most satellites in orbit at a couple hundred, or excuse me, at about 100. And so we were trying to 15x that. And that's where the term mega constellation came to be. And so, being a young engineer, I was like, sure, let's do that. Sounds easy. That's where we kind of, ran into this problem of operations and automation. But that's where I got a lot of my lessons learned and experience with operations for design and test for satellites. And then before that, I was at Lockheed Martin. So much larger company. I was working as an electrical test engineer in the factory, testing satellites, which was fantastic. I was testing a large size of a school bus satellite that provided 3G services to our armed forces. And that was great. Got to test a lot with Test Like You Fly, they call it. So they do a bunch of environmental testing, which mimics in the rocket, it going up and the shake and acoustics that it's going to feel. So you kind of try to mimic that on the ground and see if it's going to break. And so luckily they don't, because the engineers are brilliant. But then the awesome cool thing with that was I got to also fly with the satellite to Cape Canaveral, integrate it with the rocket or the launch vehicle, as we typically call it in the industry. And we did a bunch of tests over there as well, just to make sure nothing happened in flight. Got to watch it go up. And the minute that it detached from the umbilical, as you might see in rocket launches, my job was done and it was on to the next satellite.
That's incredible. Where did the fascination with satellites come from?
So believe it or not, my undergraduate degree is actually in meteorology. So it's in, studying weather. So when Twister came out, that's what I wanted to be. I wanted to be a tornado chaser. I wanted to be the guy on TV, in the middle of a hurricane, getting blown and, blown away. And, a part of that at Michigan, I joined a balloon club, and that balloon club I thought was a weather balloon club. And instead, they were actually testing small satellite components on weather balloons and then getting them back. So instead of sending them to space and never getting them back again, they could launch them at high altitude, 120,000 feet, and retrieve them and see if their experiment worked. And a part of that, I got fascinated with, okay, if I'm the weather person for this team, they want to predict where a balloon, when you launch it, and to where it pops and where it lands so that you can safely retrieve your payload. I need real-time data from the balloon. I can't just use the models that are produced every 6 hours, every hour, depending on which model you use. And so that's when I started to understand software and electronics and to try to create like a weather sensor that could telemeter real-time weather data down to the ground. And, it kind of took me a second and realized, well, this is actually what a satellite does. And I started to learn electronics. And as I, wanted to progress my career, I decided, maybe it's a good idea to learn satellite systems engineering. And so I went to grad school for that. And that's kind of what took off with me and satellites.
That's incredible. It's funny, the question. I was just watching something on Netflix, and it was around the how weather's predicted, and it was talking about the network of satellites, and then on the ground, how the network of satellites kind of communicates with a bunch of ground technology to interpret the data and then push it out to different local channels. And it's this cascade effect that then we get, the information that we have on our phones and our applications. So it's so fascinating how the network kind of cohesively, gives you information that obviously comes so quickly and so readily. Outside of weather and the other types of information, I think and I guess that we relate with satellites, like our phone service. What other information is being gathered from the network of satellites that we may not know of?
Yeah, no, especially in the last 5 years, sci-fi has almost become real with what we're trying to do in space with satellites, with spacecraft. And so kind of like the big kahunas out there are Earth observations, taking pictures, optical, as I mentioned, the new kind of synthetic aperture radar, taking them and they look like black and white photos and radar. Commercial GPS or position, navigation, and time is the more appropriate word. Is becoming a thing, trying to have more secure, reliable GPS out there. And then in-space manufacturing is becoming a thing, whether it's refueling satellites or actually like building components in space with spacecraft. And, recently within the last year or two, NASA has looked to outside commercial companies to build a commercial ISS essentially. And so there's three big primes who are working to compete to be a commercial space station as a follow-on to the ISS. And then going to the moon. Going to the moon is a big one now too, is starting the lunar economy. And the part about being out there too is as you start to get into orbits that are further and further away from Earth, you can actually view other satellites. And so the government's interested to see what are other countries doing with their satellites as well. So in reconnaissance, and then finally it's, data relay and broadband and direct from satellites to your cell phone to be able to make an emergency text when you're in the middle of nowhere. Or just, while you're on a plane is to seamlessly walk onto a plane and never lose your cell phone connection. So a really exciting time in aerospace.
That's incredible. And what, in terms of the advancements and this whole commercial, there's so many different topics that you touched upon that we can dive into, but I'm so fascinated just in how it involves kind of, or affects the technology that we have. You talk about signals in your cell phone and not being able to be disrupted. What was the incumbent before having this technology? Was it kind of a more centralized location that the information would be sent to, and then it would be then dispersed? Is that kind of what it was before, and where is it leading to now? Is it like really direct communication to our devices or our personal use kind of devices?
Yeah, I would say it's seamless connection. Like that's where the industry is going. It's not having to buy another device to be able to talk to a satellite. And these other devices are usually much more clunkier, than your iPhone or your Android. And no one wants to carry around multiple devices. The less that we have to carry around, similar to space, size, weight, power is everything, swap. And so the less that we have to do and the more that it's integrated, and that's where, it goes down to the manufacturers of the cell phones and the chips that are in the cell phones and getting ahead of the curve to know that the iPhone, let's just say 17 or 20, like what's going to be in there so that we can deploy satellite services that are just as seamless with those next generations of cell phones.
Yeah. What does the collaboration look like with like private commercial companies and government, and then also companies like yours that it sounds like enables this, this kind of, I would say, design, but also this implementation of this technology. It sounds like you kind of the vehicle that helps all this data kind of progress. Correct me if I'm wrong, of course, but yeah, what does the communication and collaboration look like now?
Yes, that's a great question. Definitely as I've been in this industry now for 8 or 9 years, it's, who you meet along the way. Same thing with college, not necessarily the grades you make, but the hands you shake. And so, part of this process, we noticed that in the furthest upstream and just like creating satellites, additive manufacturing, 3D printing is allowing more affordable manufacturing and at scale of satellites. And so the price has really gone down, and now customers, want more data, which usually means more satellites, and they want quicker data. They want the latency to be much quicker than what you would get with, even a satellite service, that's internet based. So they want that quick and snappy. And so they want more satellites. And then the next phase in that is the ground stations are the antennas. And so the antennas are really more now like Airbnb, where you can rent them by the minute, which I know is not like Airbnb, but there's other, customers who are competing for time on that antenna. But it's great because it allows more companies to access that without having to build out their own infrastructure. And honestly, it can be like ice road truckers when creating and deploying these antennas where, very northern and southern latitude regions where your satellite, if you're in low Earth orbit, is going to pass very, very frequently around. You have to work against the elements and the weather and the tundra to be able to, take heavy equipment along, permafrost, and then to be able to, dig trenches and stuff when it's thawed, and then, to complete the circle. So antennas as a service has helped, open up that area. And then finally, as a lot of folks have seen with, SpaceX and some of the other smaller launch companies, like Firefly and Astra and Rocket Lab, they're creating much more affordable launch vehicles that can take smaller satellites, and more companies can afford to get to space, which is typically the most expensive part of, your satellite procurement and creation and deployment. And where we're at is we're the midstream there. So all of that has become, a focus of the industry as it should be. But every single satellite that's out there, every single spacecraft that's out there needs communication with the ground, and they need operations. And so as we have more satellites and as space gets even busier and as we have more launches, you need to be able to scale up operations more of like IT as if you just deployed another server. And so that's where Quindar comes in.
That's incredible. And what about, what Quindar is doing? You said it's operationalizing this whole process and making it not only accessible, but efficient as well. What are some of the exciting kind of projects that you're working on, or companies that you're working with to kind of, use this technology and advance it and gather more different types of data? Tell us a little bit about the traction and the progress that you're seeing.
Yeah, I can't name any specific companies just yet, but just as I was mentioning with like the types of customers, we have a diverse set of users, whether that is the in-space manufacturing, Earth observation, telecom. A lot of those have come to us seeking help with operations. And it's because of a few things. And, it's a tough market to hire in. People are expensive, especially aerospace engineers are very, very expensive. And so what you see in like the Apollo 13 and a lot of like famous images of people in a control room with dozens and dozens of screens and like the huge screen in the front, that's exactly what operations is still like. It really hasn't progressed much in the last couple decades. And so it's futuristic as like space sounds. It's very archaic behind the scenes because what has worked in the past, that's what people like. And it's like, well, it works. Space is risky. We can't get it back, so we're going to keep on moving. But the industry is moving much, much faster. And so our services are able to onboard those diverse set of customers and abstract away the year, 2 years it would take them to create the same sort of software on the ground to be able to track a satellite, which is complex orbital mechanics and mathematics, to be able to reserve contacts. Now you know where it's going. You have to reserve antennas that are all around the world and know when is it going to pass overhead and for how long. And so being able to reserve those times, we abstract that away as well. And then every satellite speaks a different language. So there's kind of like a funny saying where it's like every satellite has its own personality. You're in this space environment. It's very dangerous. There's something called a single event upset, which is just radiation particles that you kind of crash your computer a little bit, and you have to be ready for those moments. And then each of these manufacturers kind of creates their own language that their satellite speaks. And so as the number of satellites and manufacturers start to increase, we're working with them to be able to have a default configuration in our platform. So even if you have with supply chain, different manufacturers making your, let's just call it your Earth observation constellation, taking pictures, we're able to handle that orchestration and understand this satellite speaks this language, this satellite speaks that language. And then finally, at the end, it's like I mentioned, it's a dangerous environment. Things go wrong and you have to be ready for that. And so that's usually what those engineers are there for, is to be ready for that moment. Cause it costs a lot of money to get up there and the satellites are expensive. We're taking all of the events that happen on board the spacecraft. Again, just think of it like a computer, your CPU, your RAM, your state of health. What was the server doing? Did it actually like accomplish its workload? That's really what you're doing on the ground, is trying to make sure things are okay. And if they're not, fix them and get back into service. And so we're automating all of that away. And so essentially the room that you'll normally see, you could be able to access it from your computer instead of going into that room itself, which during the pandemic, NASA and JPL proved to be by operating, the Mars rover from home. And I think that's really what woke the industry up was, well, if NASA can do this and is willing to do this, then maybe the industry can also do this as well.
That's incredible. When I hear the language, I work with a lot of engineers, and so I'm thinking like Python, Java. I'm thinking all these, the coding languages. But is it similar? Are there like specific languages? I know you said they all speak different languages and have different personalities, but are they kind of built and cut like software languages as well?
I wish. A lot of it's based off heritage. Some of the new space companies are actually creating satellites that are more like servers. So the same way that you would connect to a remote server that's, for example, hosted in AWS, would be a similar sort of protocol to connect to your satellite. On the ground, yeah, we do use like common languages like that, like Python and Java. But on board the satellite, they're usually embedded programming written in C, C++, and things like that.
Yeah, yeah. I'm curious, kind of with the evolution of Quindar and what you're building. How is it? What are the different like challenges that you face working with technology in space and private companies and government that are just different than most companies, most startups that are working with software and I guess more consumer accessible products versus this seems like highly technical, highly specific, and kind of a small group of people who are working on it. What are those different challenges that you face?
Yeah, that's a great question. Believe it or not, like the aerospace industry is starting to move towards the cloud. A lot of it was servers hosted at data centers that they maintained because it's like, well, this is my data. I trust, my data to be owned and managed by my people. And the cloud's been around for, I don't know, 15, 16, 17 years as like a public service. And we're just starting to migrate back into, using that as a service. So that's like the first one is, trust in using the cloud. The second one would be, it's pretty common for satellite operations to be in a physical location that the only way to be able to tell your satellite to take a picture is to physically be in that building. And so kind of as you could see with the pandemic and the work from home movement, that was really the catalyst that pushed folks to say, we need to go into the cloud and we need to be able to, operate securely from home. And so it's our philosophy that, security is number one with us. It's absolutely number one. We want to be able to support the government as well. And that starts day one, not when you're getting a customer and they're doing a security review. That starts with your developers, all the way down there. And, with that baseline, if you can do your banking online, if you can store your passwords online, kind of like the core of living, then you can tell a satellite to take a picture online.
Yeah. Who are the major cloud service companies for satellites and information like that?
Yeah. So really it's up to the architect to be able to develop the ground system, to be able to track the satellite and contact it and deploy the services to be able to encode and decode the language the satellite speaks. And so like your Microsoft, your AWS, like those are the big carriers, and they're starting to get more space ecosystem within those cloud platforms. Like there's Azure Orbital, which is their version of being able to rent ground station time and antenna time without having to go through like those antenna experts, if you will, that'll onboard you. Same thing with AWS. They did the same thing. And so, as their meat and potatoes, those companies' meat and potatoes is that they are infrastructure. And so they're able to take just we call it wideband data, just a lot of data that your pictures, for example, and they're able to almost instantly get it to the customer so that they can begin processing. Whereas if you didn't have that backbone, it's going to be very, very expensive to talk to your internet service provider to be able to get that sort of bandwidth, because these antennas aren't located like in the middle of cities typically where there's good infrastructure, or in the US, when there's great infrastructure. They could be in Ghana. They could be in, northern Alaska, which, believe it or not, I was told in 2016 when I was at OneWeb that it was quicker to fly an MRI from a hospital to another hospital than it was to upload and download it. So even, in the US, the infrastructure in some places isn't there. And that's where these antenna providers are starting to get the benefits of working with the cloud station providers.
Yeah. As we commercialize satellites and kind of this whole process within private companies and different service providers and things like that, is there going to be a day soon or in the near future where we are, very much seeing satellites, kind of a huge web and network, as we look up at the sky? Is that going to be the reality at one day?
Hopefully we don't see them. They're definitely the concern, though, as these satellites, as they start to populate. I know like Starlink went through it with astronomers, saying that as they were looking through their telescopes, they were getting the reflection back from the solar arrays of the satellite, and it was messing up with their deep space imaging. So hopefully, and there's a push in the industry to be able to, make satellites more dark, which does have its like thermal issues in space. But yeah, I think, for you and I hopefully we don't notice it because it's seamlessly integrated into all the products we use today. But hopefully we notice it in the sense that in your car, for example, like you now have your hotspot, like you now have internet, like you really don't lose connection to cell, to wireless. And then to be able to stream and get data from all those places, like on a plane, like you'll be able to watch Netflix, and to do everything you can. And especially with business, like not watching Netflix, but, being able to work on a plane and almost like not lose your day is super important, just the economy itself. I know like John Deere just came out with a request for proposal to integrate, IoT on their tractors. Those are in the middle of nowhere. So farmers are going to start seeing, economic, benefits to access to data in those remote areas. So I'm super excited to see all the other, projects that are out there to get us data where we normally don't, and where we understand we don't.
Yeah. Yeah. It's incredible what the amount of information and how it leads to just progress and giving the capabilities. It's, not the first thing or the first use case that, generally is the most innovative piece, but it's what trickles down from that. And yeah, like the farming piece is so fascinating, especially as, the population's growing and access to food and just supply and everything like that needs to be, I don't know if it's further regulated or just further accessible in a lot of ways. And I think it's just knowing pieces of information that get us there. But in regards to, Quindar and what you're building, what are some of the biggest risks that you face today?
Yeah, so we're a new company. We founded in March of this year of 2022. And so we started from scratch. However, we've have experience, at our previous 2 to 3 companies, depending on who you talk to, with operating satellites. And our team is actually 5 other co-founders. There's 6 of us total that we started, and we've been together across 2 companies over the last 6 to 7 years. And so we do have a brand about being able to operate, satellites, a large number of satellites in a diverse set of satellites. That does help, but the product and the solution is large. It's a large footprint, and a couple weeks after we incorporated, we all got together. We're all technical. We're not business, and so like we had to start learning, the school of hard knocks of business. And so we started with Y-Combinator Startup School, which was great because it kind of reversed our path. And instead of us saying, we've done this before, we know the solution, is to actually go talk to whom essentially would be our customers, figure out what their pain points are, and find what the best solution, which they often don't know the solution, the best solution for them. And as we kind of went through that process, we saw in the top right corner, whatever, the website that YC was accepting applications, but they were due in like a week, and we didn't necessarily have like the solution yet. We were still talking to customers and stuff. And I was like, well, I guess Gretzky said it, you miss 100% of the shots you don't take. And I was like, at least let's say that we had a chance to say yes or no, or to get an interview versus not knowing at all. And so I applied, read through their tips and practices. We got an interview, which I think they said this year they did 1,400 interviews of like 14,000 or something like that candidates. I thought we did terrible during that interview, and they asked us all business questions, and I was ready for technical questions. And so I was like, guys, it was a great run. Obviously this just wasn't going to be for us. We learned a lot from that moment. 2 days later, I got a phone call, and our group partner was like, we don't normally fund 6 co-founders. That's a lot. But because of what your team's been through and what you've done, we're going to take a chance. And so you guys are accepted. And that, I think, set us up for a lot of the success and traction that we're seeing today, because we didn't have a product. We didn't have the solution. And building it from scratch in the aerospace industry, aerospace traditionally is built off heritage, and it had to have worked before against another satellite. And we didn't have that. But building out and talking to our users and gaining their trust, and especially as I learned with, sales and business, it's all about relationships. And that's what OneWeb brought us, which, is unfortunate to be a part of. One of the worst days of my life, in March of 2020, when they filed for Chapter 11 after raising billions of dollars and having launched their like 70th or so satellite successfully, which is usually when you invest in companies, is like they're doing what they said, they're getting their traction, but the stock market crashed. No one knew what was happening. And 400 plus of our employees were laid off in a day without being in the same room to say goodbye. But the thing that happened with that was all those employees who did a fantastic job to build the company that is there today went and sprinkled all around the aerospace industry. And so we've been utilizing a lot of like those relationships, to gain that trust and to be able to not give pilots, but work with them on our pilots of our service, so that we can continue to build out.
Yeah. What was the most compelling reason that you feel, YC kind of put their faith in the overall kind of vision of the product? And I know you said, at that point you didn't have a product, but I was told by a founder on one of my episodes, I think it was the founder of Boomtown, but he's like, product market fit is a point in time. And so compelling because it's true. You continue to iterate and fit your product, and it evolves throughout the longevity of your business. But what was the most compelling thing that you think they saw in wanting to involve themselves in a project like yours?
Yeah, without a doubt, our team. Like our team is very diverse in the software skills and aerospace understanding for the complex mathematics behind flight dynamics, behind the complexity of hundreds of satellites, but only a dozen or so antennas. So you got to pick which one to talk to. The language that satellite speaks, like that was my role at OneWeb, for example, or the analytics. Like another one of our founders, worked on the analytics and stuff. Another one worked on, infrastructure and kind of gluing everything together. And so with our powers combined, like we can build this, we have built this, and the team that's behind it, not only on the technical side, we also complement each other like on the business side, whether it's, someone wants to grow their career on the legal or the finances or the business development. When we voted on positions even, none of us voted for the same position. So wow, kind of an easy decision to make about like what everyone's doing.
Yeah. What makes your job particularly hard?
I mean, I'm learning sales and business. And so, it is a different beast than being able to create internally the solution that's going to work, because even, in our previous jobs, we would talk to like the people who would use the software, probably not as much as we should have. And that was really drilled into us at YC, was to consistently be talking to our users. And so it's, difficult, gaining that trust and that this product that, is being built for satellites is going to work and be better, more affordable, have higher performance, and it's going to make them look like the hero. Like our buyer persona is like the managers, the VPs, the director, because we're enterprise sales, and our job is to make them look like the heroes. And so learning all of that has been a wild ride.
Yeah, yeah, I can imagine. I always like to just, kind of think about the future as companies are building. I know you just launched in March 2022 this year, and that's incredible to see where you've gone now and also where the kind of the future is headed. But if everything goes well, what's the long-term vision for Quindar?
Yeah, the long-term vision is everything is flipped. Right now, we're building software on the ground, and it is rare for an aerospace company to be completely software, not having the capex of hardware. And it's expensive. It is expensive to build a satellite constellation, and we're completely software. It makes us very affordable. And where that's going though is what's on the ground needs to be in the satellite. Instead of us wondering what's going on with the satellite and saying, I need to talk to it every 6 hours, just check up on it, like a parent checking up on a kid. It needs to be like an IoT device. When something's wrong, it's phoning home. It's going to phone home to say like, hey, do I need a software update? Is there any, is there any software update that's ready for me? And we'd be like, no, there's not. Or to be able to talk, crosslinks, they're called. So from satellite to satellite. And so essentially ground stations in space instead of like the terrestrial hardware that you would have on the ground. And that's where we want to elevate ourselves to, is from ground software to onboard flight software.
Yeah, yeah, no, that's incredible. And I can only imagine the ability for it to affect so positively the different industries that use that information or can use that information, and lowering the barrier to entry is only gonna, grow that exponentially. I always like to ask this selfishly for my own research, but also for my audience. What books or people have influenced you the most?
Yeah, I'd say one of the books is a classic in the business and startup. Definitely Lean Startup. I probably read that 3 or 4 times, which it's almost ingrained now in my brain about like, how to even operate a team. You don't even have to be a startup, but even like operating a team and acting like one. The second one I would say is Build by Tony Sedell. So, the inventor of Nest, and the iPhone and stuff. And just realizing that, the first touch point, that first mile, that's the customer's, that is what the customer is going to think of the company and of the product. And it's so important to have like your user interface very friendly and understandable. And what we're making is not that you need to hire these specialists to be able to track and contact a satellite, but whereas like a normal, anyone almost could be able to operate a satellite with our platform. And the user interface is going to solve a lot of those problems that software can't. There's definitely a lot in the back end, and that's what we did before, but that first mile is so important.
Yeah, yeah, that's so exciting. And Nate, I know we're at time here, and thank you so much for being on the show. I'm so excited to see, where the evolution of this technology kind of interacts with us on the daily, in our daily lives, and how it really progress different things. Technology, but also just like, experience and culture and society, and in so many ways, it just seems like, moving this forward is going to influence us a lot. So I hope you enjoyed your time, and I always kind of like our founders to have a chance to let us know where to support their business. So where can we? This is the chance for all your plugs. Where can we find Quindar? Give us your LinkedIn's, your Twitters, anything under the sun that we can get involved to support you and the mission.
Yep. We're at Quindar.space, links there to our LinkedIn, to our Twitter. We're always looking for partnerships to enhance, our capabilities with operating satellites. There's a lot out there. Obviously customers, who are looking to build their own constellation. Don't worry about the operations, focus on the challenging stuff. And this is a utility that Quindar can handle.
Incredible. Nate, thank you so much for being on the show. I really hope you enjoyed yourself.
Awesome. It was great being here. Thanks, Julian.
Thanks.